Good morning all of you. In the last lecture we have seen about the types of the shallow foundations, bearing capacities, and today we are going to see what are the different groundwater table properties and how we are going to relate it with respect to the footing. So normally when we say for the shallow foundation, the effect of the water table is with respect to the soil and with respect to the depth. So first of all, let us see that how a rising water table have the following adverse effects. The first one is appreciable reduction in the bearing capacity. Second is the development of the uplift pressure. Obviously in the soil and the foundation will be having the pressure differences. Possible ground heave due to the reduction of the effective stress caused by the increasing pore water pressures. Expansion of the heavily compacted fills under the foundation, appreciable settlements of the poorly compacted fills. So when we talk the rise of the water table with respect to the soil and with respect to the depth of the foundation, we'll be seeing two different cases that will be adding as the water table reduction factors. So in the next slide, we are going to see how these reduction factors are affected and how with respect to the depth they are counted. Okay, so this were the bearing capacity of the footings, in which we had the strip footing, circular footing, square footing and rectangular footing. When we see what are the differences in these footings or differences in all these formulas, we will be saying mainly the constants. So two different constants are added for the effect of the water table fluctuations, and those are Rw1 and Rw2. So the new formula, it goes as Q is equals to C CNC plus gamma D and Q Rw1 plus 0.5 gamma B and gamma and Rw2. Now we will see how to find Rw1 and our Rw2 in our next slide. Next. So the first case goes as Rw1 is equals to 1/2 into 1 plus Zw1 upon D, in which in the figure we have been seeing that we are having a footing over there which is having a breadth of the footing, we are having depth of the footing, and when we talk about this height, that is with respect to the ground level and with respect to the water table level, this difference is our Zw1. And when we talk about this Zw1, it always shows the different properties of the gamma, that is, this is our normal gamma, dry gamma, and this is our saturated gamma, in which both the values would be different. Depth, we already know these things. When we talk for the same case, that is our case 2, in case 2 we are having the groundwater table that is coming below the depth of the foundation, that is below the base of the foundation. So this is our Zw2, and this is the total flooring, or we can say the total depth, how much we are going below it. Rw2 is equals to 1/2, 1 plus Zw2 by B. It has been already said where Zw1 is the depth of the water table from the ground level and Zw2 is the depth of water table from the foundation level. Whenever we are seeing in the numericals, what we see? In numericals we have been given two different cases, or we can say three different cases. What would be the third case? When this water table would be at the depth of the foundation. That would be our third case. So in third case, what will be happening? Gamma 1 and gamma 2. That would be at different levels, but it would be at the height of the depth of the foundation, or the base of the foundation. So these two cases, when the numericals are being asked, what we'll be seeing? The first thing is the depth of the foundation and the level of the groundwater table. So when we consider these cases, three different cases will be having, and accordingly the whole numerical we will be solving. So in our next slide, we will be seeing how these cases are taking relevant things. Okay. So the next thing that we are going to do is the settlement of the shallow foundation. Now why we are studying right now the settlements of the shallow foundation? Because when we consider the water table, that is our groundwater table, with respect to our ground, what will be happening? There would be some settlement, whether the water table would be above the footing or below the footing. So the settlement of the foundation are having, or it has been influenced by three different factors. S is SI plus SC plus SS. What do you mean by SI? That is the first thing, immediate settlement. SC is our primary consolidation and SS is our secondary consolidation. Let us start with the final settlement with respect to the first factor, immediate settlement. SI is equals to QB upon E into 1 minus mu square into IF. Considering all these terms, we already know all these terms. One new factor that we are finding, that is IF, that is our influence factor, and the values of the influence factor for the different different types of the footings, it has been given. So how they are changing, that is for the shape of the circular, square, rectangular footing, it is the influence factors are coming as for the center corner and the average. That is when we talk about the foundation, we are having a bigger size. So how this are being changed? For the center we are having I, for the corners we are having 0.64, and the average values that we are taking is 0.85. So according to the different shapes, the settlement also considers. These are the settlements of the shallow foundation with respect to the immediate settlement. Now when we take about the immediate settlements, that are the that is first thing that is coming. Second thing that is coming is our primary consolidation. So in the next slide we will be seeing over the primary consolidation. The primary consolidation settlement SC is given by the formula lambda into CC upon 1 plus E0 into H log sigma 0 plus delta sigma upon sigma 0. In this also we are having one main thing, that is our lambda, because all the terms that we have already seen, we already know what are the meaning of these things with respect to the depth of the foundation, with respect to the water table, with respect to the stress that we are having, and with respect to the void ratio that we are having in the soil. So when we talk about the values of lambda for the different types of soil, we are having very sensitive clays, obviously that will be having normal consolidation clay, over consolidation clay, heavily over consolidation clay. All these types of clay that are with respect to the water tables. For example, in a particular depth of the soil or depth of the ground, as we increases the water table or as the amount of water in the soil changes. So all the types of clay are with respect to the water amount. So when we are having a small amount of the water amount, the values of the lambda is for 1 to 1.2. When the water amount increases, the lambda decreases, and the values we can already see in the normal consolidated clays, it is 0.721. Over consolidated clays we are having 0.5 to 0.7. In heavily over consolidated clays we are having 0.2 to 0.5. So in a primary consolidation, when we talk about, it depends on all these factors. Now as we increase with respect to the primary consolidation, we will be having the secondary consolidation. That would be in our next thing. So secondary consolidation settlements is the more important and most important in the case of organic and highly compressible inorganic clays, which is given by, we are having the same formula for that. That is, the secondary consolidation is equals to C alpha HC upon 1 plus EP log T2 by T1. And when we carry out this whole secondary procedure is going on with respect to the foundation, what happens? It's a time-based thing, because secondary consolidation cannot be done or cannot be completed at all the footings. It depends on the load that is coming, it depends on the type of the foundation, it depends on the shape of the foundation, and it depends on the type of the clay that we saw in the previous slide. So this is C alpha. What is C alpha? Secondary compressible index that depends on delta E upon log T2 upon T1. That is the initially time and the final time. And when we talk about the log scale, that is the void ratio versus time, what we are going to see that as the void ratio increases with respect to the time scale, it decreases. So in the initial stage we had this much amount of voids in our soil, and as the time increased, as the load was coming on the soil and the foundation, this was getting decreases. So with respect to the initial time T1, with respect to the initial or the final time T2, we are having the different